Rotate if you want that or whatever. Okay, you guys, welcome. Today, like you might think, gee, a little bit ambitious there, Mr. Royals, 12G, H and I. But we'll talk about 12G, okay? It's a reasonably straightforward skill and it's fun, okay? It's fun. All right, 12H is exponential graphs and it's largely using a calculator. And 12I is growth and decay. Now both H and I you have done in year 10. Okay, you've done it before, and so we're going over it quite quickly. I think this is a new skill. So we're going to start the lesson with G, and then we'll go through H and I. Now, you will see it is probably pretty ambitious, this lesson and Monday's lesson, but that's because what I have planned on Tuesday is an optional extension lesson that I would like to go through if some of you are interested, because it will be useful to year 12. Okay, so that means we have Monday, Thursday, isn't it? So Thursday next week will sort of be a catch-up / extension lesson. Okay, so that's why I'm sort of trying to go through some of these things pretty quickly, because we have had some exposure to it before, and to give some of you guys the opportunity to extend yourself if you're interested. Okay. So here we are, solving exponential equations, and we're solving them by equating the bases. So this is the first one. We have 3 to the power of x equals 9, and you might be able to look at that and go, oh, I can see what the solution is. But let's talk about the process behind it. What we need to do is we need to make this and this have the same base. Okay, so 9, well that's 3 squared. Now because the bases are the same, therefore the powers are also equal to one another. So therefore we have x is 2. That's our solution to the first problem. Fun. Okay, second one, we've got 5 to the x is 1 on 625. Now what I've put up here is the first 5 powers of the first 3 prime numbers. So we've got 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, etc. 3 to the power 1, 3 squared, 3 to the 3, 3 to the 4, and then 5. Okay? So we can see 625, that's 5 to the power of 4. So what we have here is we've got 5 to the x equals 1 on top of 5 to the power of 4. All right? Now we're sort of expected to sort of know these, or begin to sort of know them. All right? At least the first 4 powers, and it's useful for the first 5. So here, what are we going to do? We need to make them have the same base. Okay, so if we have 1 on 5 to the 4, we can write that as 5 to the power of minus 4. And then we have the same base, so let's equate the powers there. X is minus 4. So there's A, there's B. And they're just going to increase in complexity a little bit. We have C, we've got 9 to the x take 3 is 1 on 27. So looking at that, we need to go, well, what's the base that they're going to have in common? And so we can look along here, which of these numbers has both 9 and 27? It's 3, okay? Base 3 has 9 and it has 27. So 9 is 3 squared. Let's do that first. And then 27 is 3 to the power of 3. Now notice how the 9 is in brackets. That's because this power is going to distribute to the 2. Okay, we're going to have that, well that 2 is going to distribute to both of those, the x and the 3. So here we're going to have 3 to the power of 2x take 6, and here we're going to have 3 to the power of minus 3. Okay, the bases are the same. We've made the bases the same, therefore we're going to equate the powers. 2x take 6 equals minus 3. We will add 6 to both sides. So we'll have 2x is positive 3, and then we'll divide both sides by 2. X is 3 on top of 2. 1.5. Okay, so what are you doing when you're solving an equation? You're saying what value of x makes this side equal to that side. Okay, and so if you put x is 1.5 into this equation, it's going to equal what we have written over here. All right. D, 3 times 4 to the x is 48. Now, when you have the difference between, if we look between this one and this one, because we have this product out the front. Now, whenever we're trying to solve an equation, we're doing the opposite of paired maths, aren't we? We're breaking it down. So that's a good way to think about solving equations, is we're doing paired maths in reverse. So there's no addition and subtraction that we need to perform here, which means we're at division and multiplication. We need to get rid of 3 first. So we're going to divide both sides by 3. And we'll have 4 to the x is 16. And then you're off to the units. 4 to the x is 42. X is 2. Okay, so let's leap straight into this. Let's do a few of these, and then we can hopefully get the hang of that and move on to H and I.